Hi, my name's Holly. Welcome to a discussion on the outcomes of the ExploreSA, the Gawler Challenge Data Prep Prize results. ExploreSA, the Gawler Challenge is one of the largest ever open data competitions run by the Government of South Australia. We're currently in the middle of the challenge, but we have just finished up the first phase, which is the Data Prep Prize, which is what we're going to be talking about today. And specifically how the outcomes of the Data Prep Prize can benefit the exploration industry broadly. So we're just going to have a bit of a discussion around that today, talking about things like data accessibility, increasing kind of access to data-driven approaches, and how we kind of use data in exploration. I'm joined by Christie and Peter today from the Department of Energy and Mining in South Australia, who are going to join this conversation, share their insights and what they've learned from the Data Prep Prize. So I will pass over to Christie and then Peter to introduce themselves, and then we'll get into the chat.
So hello everyone, so my name's Christie Gerrard. I've been working with the department for probably around just over 10 years. So I'm currently the Sarek manager, so my role is to sort of manage all the data delivery that comes out of the department from the minerals and the petroleum side. So I suppose this was a really good challenge, the Data Prep Prize, because I had some really interest in what people were doing with the data. So that's me. Peter? Yep.
Hello everybody, my name is Peter Buxton. I have the rather long-winded title of Program Coordinator, Geoscience Information Management and Delivery with Geological Survey. My role is more around supporting the underlying data that is delivered via Sarek. So I sort of look after the back-end databases and that sort of thing.
Awesome, thanks. Well, to give everyone who's dialing in a little bit of background, the ExploreSA Challenge is, a challenge that invites people from all around the world to, look through all the open data that South Australia has and come up with new mineral exploration targets. And we know that there's a lot of work that goes into kind of getting some of these data sets ready to use, particularly in machine learning models, which is why we kind of devised this Data Prep Prize. So as we kind of get into the discussion, we'll kind of delve into a little bit about some of the data sets, about kind of issues that we see, how this kind of challenge helped kind of approach some of those issues. And we know we've got a lot of different data sets that are available via Sarek. So actually, Christie, would you mind just breaking us down for anyone that is dialing in what Sarek stands for and what it is?
Yeah, sure. So Sarek is the South Australian Resources Information Gateway. So that's the acronym explained. So really it is just it's a mapping portal. It's anyone can use it, so it's freely available. And really what it is there for is for people to come on and access exploration data. So basically, we've been collating data for about 130 years. So it's all that rich history of what people have done, all the exploration companies. So all that data is available. Also, sort of with the company reports as well. We also use Sarek for really to attract investment to the state as well. So we have some really nice dashboards that show, highlight some of our commodities, where the commodities sort of are around the state. So really it is just a big information portal. It's a mapping portal. So we have over probably nearly 700 layers, which cross from images, from geophysics to all of our commodity layers. We run into mineral tenement layers as well. So people can come on and actually do the admin of mineral tenements as well. So it really is just a broad way to access data from the state.
Awesome, thanks. I suppose I should mention as well, ExploreSA is focused on the Gawler, hence the title of the Gawler Challenge. So all of the data that we're pointing people to for the challenges is in the Gawler region. One of the most commonly used data sets, probably that you guys curate and host, is the geochemistry. I know myself as an exploration geologist spending a lot of time going through very large geochemistry data sets as they're trying to kind of pick up new projects and things like that. As kind of an interest as part of this Data Prep Challenge, would you be able to share some of the kind of common problems you see with people trying to use this data set, particularly because it's kind of so large and there's quite a lot of, I guess, changes in it as data has been collected over time. I guess, Christie, if you wouldn't mind starting with some of your insights on that.
Yeah, I mean, I suppose we've you know, for the delivery through Sarek, there is always a challenge with our geochem because it is a statewide data set. So, and it's been collated over, as we said, decades. So really, we've had a lot of formats coming in. So from, you know, manual to now moving to digital. And I suppose it's one of those data sets where it's big. We technically, you know, we know people, you know, would like a data set that is statewide, but we have challenges with that within ourselves because, yes, we can deliver a statewide data set of all the geochem, but you can't open it in just Excel or even Notepad or and things like that. So it has been a challenge for us on how to get that out to the public. And I suppose, again, with that historic, you know, on the ways that it's been imported into databases and it, again, it's like, you know, it's what comes in is what's coming out. And I know Pete has some definite challenges around that side from the database side. But yeah, I don't know, Pete, do you want to have a bit of a talk about that?
Yeah, well, I guess as you alluded, Christie, it's a very significant data set. It's probably far and away the biggest component in terms of the volume of the data that we manage. There's something like 30 million analytical results just for the rock samples. So it is a massive data set. It's a significant effort on our part to keep it on top of getting the data in, and we know that geochemical data does have not a huge issue, but it does have issues around QA, QC, and we manage some of those reasonably well on the way in, but some of them we don't manage particularly well, and everyone struggles in this space. So we know that within that data set there are issues and there are errors. The bulk of the data set, we genuinely believe is fairly sound, but identifying those errors and managing those errors when you've got 30 million records to deal with is a significant issue for us.
I think some of the nature of that data set as well, it's not necessarily the errors per se that make it difficult to use, but just that, you know, as we said before, it's been collected over decades with different sample types, different assay methods, detection limits change over time. So all of those things mean that if you look at the data set as a whole, it's actually kind of multiple, like hundreds of different kind of populations almost, and it becomes really difficult to use as an overall data set without kind of breaking it down into those populations to apply kind of meaningful analytical approaches to it. Which I think is, you know, one of the things that really got picked up on quite a lot of the submissions is that need to kind of understand how do we actually break down the data set in a meaningful way, and that we acknowledging that some of those, you know, different sample populations are there, we can still actually use the data in a meaningful way. So I wonder if you guys could comment on anything interesting, that you saw in the submissions that came through that kind of help people deal with some of the inherent issues of geochemistry.
Yeah, well, absolutely. I think you're quite right, Holly, that sort of that history of the data and the long period that we've been collecting the data over is an issue that needs to be managed carefully while you're using the data. And I think, yeah, there were definitely some submissions that took some very interesting approaches to how you dealt with the different analytical techniques and the different populations, even just based on the type of sample and that sort of thing that you were dealing with, all of which can have an influence on how you want to think about and make use of the data that's there. There were certainly some very interesting approaches to identifying anomalous data, that needed a bit further investigation to understand whether it really was data with an issue or whether it was, whether the data was valid and usable in its current form. So those in particular, I think, were from my perspective, in terms of just managing the data and identifying those issues, those particular approaches were quite interesting and quite useful, I believe, for us to be able to apply going forward in just identifying and managing some of those issues, and probably even building processes that can help us manage those issues on the way into the database, so it's not so labour intensive for us to manage going forward.
Yeah, Christie, was there anything you saw?
Yeah, I mean, for me, I've got the challenge of how we display on Sarek on the map. So, and at the moment, our geochem, it really just is an indicator. There's a dot on the map that says, yes, there's been some geochemistry, you know, taken from that location. So for me, I'm definitely looking at ways on how we can better visualize, I suppose, the geochemistry. And there was one submission that, you know, that really, again, to me, it confirmed that people are interested in the commodities. So, you know, where is the copper, where is the gold? And so I think one of those submissions I kind of leaned to, because I thought, wow, you know, there's something that probably I can do on Sarek on how we can display the data. And then it's also subsetting it as well, because, you know, with Sarek, we can't even display the rock sample and data set at full at state level, because it's just too big a data set. So, but again, how I can subset the data and how I can display it, maybe in, you know, certain commodities, either a range or, you know, I'm kind of thinking maybe end of hole, maximum depth or something, you know, like that. Yeah, so I think, you know, for me, it was, you know, ways on how I can better visualize and, you know, and deliver the data, the assay data for Sarek to the public.
I think one of the other ones that I saw that kind of, yeah, really threw me back to my days working as a geologist was that the submission that kind of transformed the data to be able to pull it easily into GIS packages. I think that's,
that was that one. Yeah,
that's something that just makes geologists' life so much easier. Like, we all still use some form of GIS usually, and it's a challenge with data sets that are so large because we can't store them in the way that we want to import them, so we kind of have to transform that to get it in. So I thought an ability to do that was really useful, and that one certainly got lots of comments as well from people saying thanks so much.
Yeah, I absolutely, because you really want to visualize the data before you kind of do anything with it, and I suppose it's highlighting those areas of the state where you might zoom into a little bit more and investigate more of the geochemistry, and it's just, for me, pinpointing and visualizing that on Sarek. I also think one of the good one, there was one submission there that sort of looked at an issue that we have on the way that we deliver our geochem. We sort of have one table, but it's very long table, and they actually flipped it and made it a wide table, which I know, you know, for explorers, you know, the geologists would prefer it in that format, because then they can just, you know, put it into a GIS package or put it into, you know, some other software quite easily. So I think for us it was really good that some of the submissions confirmed some of our thinking, and we can, you know, have a look at the code and see what we can do within our own systems.
Yeah, I think that's one of the important things, that a lot of the code is there and included in a lot of the submissions, that can be the process that people followed are easily replicable. I mean, Peter, you mentioned a bit about kind of improving your data pipelines and things like that. I think that's something kind of hearing from a number of people. Obviously, there's quite a lot of groups out there that have kind of proprietary you know, data ingestion pipelines and things like that. Is there anything that you can share about what you've learned that can improve your processes? What are the things you're going to take on board from that aspect?
Yeah, well, I mean, look, for me, I think, and this is going to sound amazingly simple, but it was just fascinating to see how the errors through the processes that were implemented sort of basically just broke down into two groups. So that in itself was an incredibly useful piece of information, because that told us where most of the errors that are coming into the system are creeping in. And if we can manage those more efficiently during our load processes, then we can probably do away with a significant amount of the errors and the issues within the data. So it was just that outcome from the process that sort of immediately spoke to me very, very quickly. it was very useful because it's something that we have kind of struggled to, I guess, manage and identify ourselves. So, and then I think there was just some ideas around, you know, one of the submissions there at the end of that process kind of put together just a very basic framework, but a bit of a framework and some thinking around how you might apply machine learning to managing and identifying some of these issues. So I think I'd be pretty interested in pursuing that idea further and just seeing what we can do in that space to automate and relieve the manual workload that's involved in a lot of these things, which is, you know, the biggest stumbling block that we have. You know, we're as with all agencies, we're very tight for human resources, and so we struggle with some of these tasks that do require a significant amount of manual intervention to manage. So that framework in itself was just a useful thing to have that we can investigate further and pursue and maybe get some real benefit out of.
Yeah, and I guess ultimately, the faster you guys can kind of ingest and output data, the faster people get access to it, right? So it's all about getting that turnaround time as fast as you can, I suppose.
Yeah, absolutely. Yeah, and it also means the more we can automate some of those things, the more we can go back to some of the data that is more historical and much more manually intensive. You know, be it handwritten data or lithological log data is another one that we struggle with. If we've freed up resources from managing some of these larger data sets that can be more readily automated, then we've got more time we can spend on some of that other data, which is still exceedingly valuable.
Cool. So I'm going to, I guess, switch direction a little bit. I think we've talked a fair bit now on, I guess, some of the direct benefits in terms of how we can directly apply the work that people did in terms of the actual code and process that they used, kind of direct benefit, whether it's, you know, and within the department or actually for explorers wanting to apply some of those techniques themselves to kind of better deal with their data and more quickly kind of analyze their data. I think one of the other kind of outcomes of a challenge like this is kind of opening our eyes a little bit to just fundamentally new ways of working with the data that we kind of haven't seen before. I mean, we had kind of an interesting discussion within our group last week around, you know, how people are using geophysical data and machine learning and whether that was appropriate or not. And yeah, I'd be interested to hear from both of you if there's anything in particular that has kind of come out of this that's been, you know, a bit of an eye-opener about this is actually quite a different way of working in something that you never thought of before.
Yep, I'm happy to go. So I suppose we definitely had some conversations. I mean, we had some different conversations around the geophysics data and, you know, and how that can be used for machine learning, which I kind of really found interesting. You know, I'm not a geophysicist, and we do deliver so much geophysical data from Sarek. So from the images to the raw data to the process data. And I think there was a really good conversation on how, you know, what sort of areas can be used for machine learning. So, because the raw data, it can be hard to consume. It can be hard to understand if you're not a geophysicist. So it was really good to hear that around the images. So we have a lot of images around geophysics and metatellurics as well, and all that sort of data, that it actually can be used in machine learning. It can be used as a tool for exploration in that sense. So yeah, I thought that was really good.
Yeah, there was one submission that I think did take some of that work that little step further, which integrated the geochemistry with the geophysics, and I thought that was a really valuable little process and exercise that was put together in that submission. Just from the perspective of bringing the two data sets together and then allowing you to interrogate and work with based on that integrated data. So I think that was certainly one of the areas that I thought was really interesting. The other area that that I thought was interesting around it was how some people put together submissions that did things that we would, things that we would do as an agency, but they were able to do them with tool sets and with computing power that was perhaps not, or was perhaps more accessible, I guess, to the average user, and where we probably depend on some fairly expensive and inaccessible software for most people out in the general public or in the general community, and just was really interesting to see people actually take the initiative and explore the capabilities of some open source software and some just some desktop computing power to really do some interesting things with geophysical data. So I think that was really valuable information to get out into the broader community, probably.
Yeah, I think it's. Oh, sorry. Go ahead, Christie.
No, just to add on that, because one of the submissions used our web services. So we've been, kind of working really hard on delivering our data in web map features. Sorry, web map services or web feature services. So it was really good. One of the submissions actually used that. Again, it was back to the geophysics, but used that and to do the work. And I thought that was really good as well. So we're trying to put out new tools for people to access the data, and it's getting picked up. So yeah, it was really good.
Yeah, it's definitely good to see people using web services. I think particularly people in the data science community are a lot more used to using that if it's available rather than kind of downloading all the data directly. Yeah, I think, Peter, going back to what you're talking about in terms of people using open source software to do some of the tasks which the survey is doing, I think it's really interesting, I think, to see like how kind of had that conversation around what's good enough. Do you need the really, really high level expert software and really, really high quality outcome, or is the kind of stuff you can do through open source software, is that good enough for the purposes of what you're trying to do? And it was really interesting to see the people who took part in that challenge, because they didn't have access to that resources, were still able to get really good outcomes. I think one of the examples we're talking about here is stitching together geophysical images and doing that on kind of open source software. And very simple submission, but super, super useful for anyone to kind of then wanting to look at that data. And kind of going back again to the machine learning thing, I think we're CEOs, as we talk to people who are kind of practicing machine learning, it's really important for them to be able to stack data sets together when they're building their training model. So they're thinking about ways of geospatially, how do we stack point geochemistry data with geophysics, and what's a meaningful way to do that. So whether that's with the raw geophysics or with the images, and how do they kind of stack them on top of each other to kind of build this training model of what features overlap with each other in space. So I think some of the approaches really did go through that in quite a lot of detail to say these are the different ways we could do it. And I think, one of the things that's been eye-opening for me and what we talked about a little bit last week was, people really using the processed geophysical images to train their models just by using RGB. Obviously, we had a chat about whether that's appropriate or not, but that seems to be the most common way that people are using the geophysical data in machine learning rather than the underlying raw data. And I don't know whether that's about accessibility or it just kind of makes the most sense given the data format or not, but I thought that was a really interesting insight as well.
Yeah, I think it. Oh, sorry, Peter, go.
No, I was just saying yes.
Yeah, I just think it was really interesting because that we just have so much data, and I think that is a bit of a challenge in itself in our current environment. So, and it is what people are doing with the different types. Because that was a surprise, because I thought, the raw data would be what everyone was looking for. So, but I thought it was really good that, just those images and the RGBs, it was used. And I just thought that is one of the challenges. We have so much data coming in from our industry now in gigabytes and gigabytes, and, all the different ways that it can be used. And I think that was really good of the submissions, that, they walk through them really quite well. you know, like tutorials. So for me, who's not a geophysicist, it was really good to see the walkthroughs with the code. And I think, yeah, it was just really good to see all those different types of data being used in all the different formats.
And I think that probably helps to highlight one of the fundamental reasons we're actually running this competition. I mean, yes, we all would love to find the new deposit out there and things like that, but from the agency's perspective, you know, one of the things that we're really interested in is learning about how people want to use this data and what of our data is useful and how is it useful and what formats work best and those sorts of things. So we are actually paying quite close attention to not just the outputs from the challenge, but to how people are making use of the inputs and where those inputs are most useful and what formats are most useful and how are people trying to use the data so that we can better understand how we can better deliver it in the most useful formats and ways that we can. So, you know, things like web services even, you know, just we're embarking very heavily on investigating and developing web services and that kind of thing. But, you know, it's encouraging to see that web services are useful into the challenge here, but how do we structure those web services? Are we structuring them the best way that we can? Those sorts of things are all really useful outcomes from this challenge.
Yeah, well, I guess on that actually, like I think we've kind of had this discussion a bit before, but you know, there's kind of different types of people using the data in the sense that you've kind of got your really traditional geologists who kind of wanting to use the data kind of probably the same way that we have, you know, for quite a while, and then when you're bringing someone from a data science domain and they probably want to use it in a bit of a different way. I wonder if there's anything you can comment on in terms of, are you seeing firstly a difference in the way people use the data in terms of, you know, what their kind of expertise is, and are you seeing any changes fundamentally in how people want to use or access the data that should kind of indicate to you that I guess things are changing in the exploration sector?
Well, I would say definitely. You know, I mean, just one of the things that we're seeing an enormous amount more of is people who just come along and say, can I have everything? Can I just have a copy of your database? Well, you know, no, you can't, basically, because there's all sorts of technical limitations to that. But the underlying data that's in there, absolutely, we want to be able to deliver that to you in ways that are effective and useful. And it's those kinds of requests are a significant struggle for us at the moment. And it's one of the reasons where web services are kind of coming to the fore. So I think there is a very clear direction that people are heading in sort of saying, we really want to be able to take the data and we want to be able to do whatever we want to do with it. And we might just want to do that on a small scale, but we also want to do it on the big scale and have access to everything and just use that in whatever innovative, fresh, new ways we can. So supporting that, you know, is a significant issue and something that I think we can learn out of these kinds of challenges. The other thing I think that probably springs to mind is just harking back to what Christie was talking about. Was it Christie or was it, I'm not sure who was talking about it just now, sorry, but someone just made the comment about, you know, you've got the traditional geologists who want to do it the way they've always done it, and then you've got the data scientists, I think that was actually you, Holly, who are, you know, approaching it from a different perspective. And I think the other thing that springs to mind out of that is that I think what this is showing us is that there are a lot of new ways that we can approach the data and approach the use of the data. And the opportunities potentially exist for us to develop not just systems to deliver data in innovative ways and new ways, but also potentially to support some of those more traditional people in thinking about how they can be a bit more innovative in the use of the data because of the formats that we're giving it to them in, and that the old traditional methods, that's fine, but you know, that may well still be a part of what you want to do. But maybe also there's some other really exciting things you can do. And because we are able to give you this data in different ways, if we can support people to learn how to use that data and get the best out of it, then I think that's a good outcome for the state.
I suppose for me, it is kind of keeping up with technology as well. So as you know, the traditional way, I can download a shapefile, a tab file, or I can access data that way, or I can now attach to a service. I find for me, looking through sort of the analytics of Sarek on how people are accessing the data, our services are really going up. So, you know, we have group services. So, you know, say for the mines and deposits, like the way people aren't kind of downloading much anymore, but they are attaching to those services. And I'm seeing a bit of a change from even the web map service to the web feature service. So people are wanting to, you know, bring in that data. And I think it was also, so to me, it's kind of the technology has changed to that machine to machine. People want to script in, they want to access the data that way, they want to query it that way. So even when we built our new catalogue, so the GeoNetwork catalogue, you know, I can see through the logs that, you know, people are definitely coming in and scripting and accessing the data that way. So I think it's a bit of a change of technology and the way people want to access our data. So yeah, I think it's definitely shifting. But we also have to cater for everyone. So so it's, you know, again, but I think, you know, moving kind of what you're talking about, that QGIS, like I think it was really good how a lot of people use the open source software, because they are catering for the open you know, services, not, you know, just the shape files and things like that. So yeah, I think it's good.
And so I'm gonna ask this question, which will definitely show me as a traditional geologist. So if someone was using QGIS and wanted to use the web services, are they able to kind of interact with the data that way, so they actually don't need to download and import it to QGIS? They can just use it directly through the web services if they're online?
Absolutely, it is so easy. It's easier than downloading. So QGIS has the ability to attach to a web feature service, a web map service, and really all we do is offer a URL, and you paste that URL in the software, and there you go. So the web map service brings in an image that you can identify, but you can't change sort of the colors, or you can't do any, you know, complex querying. So that's when you want to move to the web feature service, and that brings in all of the data. So yeah, really, really easy.
Cool. So any geologists listening, go and try that after this. I guess that kind of leads on to my kind of last-ish question, which is on the submissions themselves. Yeah, how would you suggest people kind of actually use them in a practical way, kind of based on what's available? If you have any comments, otherwise I can comment.
I'm happy to have a bit of a comment. I mean, I think it's just coming and jumping on and having a look at them. I think you don't have to be a geologist, or you didn't have to be a data scientist to sort of get the best out of those submissions. I mean, we all have our different kind of backgrounds, but because of the way, you know, they were formatted with, you know, some of them had really nice walkthroughs, loved how they had screenshots of Sarek and our catalogue and how to access all the data. So, you know, some of them were really, really easy to walk through, and, you know, and sort of saying what they're trying to achieve and what they achieved at the end. You know, even having all of the data downloads available of all their subsets, say of the geochem, and what they did with that. Yeah, it was good.
Right. Any comments, Peter?
Yeah, no, I think Christie's kind of covered off on that fairly well. I think we're definitely thinking about how we can make use of delivering the information that's been compiled in these submissions as an ongoing basis beyond the life of the competition. So certainly, as you're very aware, you can access that information through the Unearthed website at this point, but we're going to definitely be looking at ways that we can publish that information and make it available to everybody in an ongoing way, and obviously, you know, acknowledging and supporting the people who've actually done the work as we do that will be a significant part of what we do. But yeah, that's probably what I'd say on that.
Yeah, awesome. I think a couple of different perspectives on using the outcomes. I suppose if you are thinking about taking part in the challenge itself, they will be very useful for you. A lot of them contain the code to process the data, but also actually the clean data outputs as well. So there's definitely some shortcut steps that you can take in terms of accessing those clean data sets if you wanted to take part in the challenge itself. I think also for explorers and geologists out there, a lot of the submissions are written, as Christie said, in kind of this kind of tutorial style. So it's very easy to understand the steps that people are taking and actually apply the code as well. So even if you're not used to using things in that way, it's actually really easy to understand and apply it. So it's a good way to kind of get a handle on what people are doing. There's also a fair bit of discussion around the machine learning aspect in there. So if you want to get an insight into why people are doing this kind of preparation for machine learning, how, and then, once they get to that point of actually trying to use machine learning, what kind of models they're thinking about, and going through those next steps. So whole wealth of information on there that's really well structured. So I think there's plenty to learn and plenty to kind of use directly from there as well, even if it's just kind of jumping on and grabbing the data sets. So I suppose to close out, I think Peter kind of already alerted to how you can access the submissions. They're all currently they're all available on the Unearthed website on the ExploreSA challenge page. So if you just head to unearthed.solutions/u, you can go on there, jump on the challenge, go to the forum, and all the submissions are listed there. So all of that's going to be kept alive, available for everyone to go and access. So jump on and have a look. I suppose Christie and Peter, I invite you to have any closing comments, questions, anything else that you want to mention before we close out?
I'd probably just say, I think what we found is that this component of the challenge was really interesting and exciting, and as we've discussed from a number of different angles today, really valuable to us as an agency, and I think the geoscience community generally, just in understanding and making use of the data. So yeah, I think it's just it was a really exciting process, and I'm very pleased that we've done it, and I'm very pleased with the outcome, and impressed by the standard of many of the submissions that came into it.
Yep, so the same as what Peter just said, really, impressed of the work that's been done. And I think it was a really good sort of, something to do before the main challenge, because it really did give the opportunity to people to have a look at our data sets, what's available from the government, and really, overview what it can be used for, and highlighting some of those issues that we do have, and how to overcome them. So, and again, the way that they were put together with the step throughs and tutorials, I think, it was, a really good sort of introduction to South Australian, the data that we provide, and how, it can be used sort of, in the machine learning space. So yeah, we're, I suppose, really now looking forward to how the competition continues. And yeah, jump on and have a look.
Yeah. So yeah, on that, I suppose there is still just over 2 months to go on the competition. It closes out on the 31st of July. So still plenty of time to get involved. You've got all these nice clean data sets to work with as well now. So if anyone is listening and interested in getting involved, still plenty of time left. I guess I would also like to close out by thanking you guys both for the conversation. It was really interesting, and also thanks to everybody that put in the work to do the Data Prep Prize. Quite a lot of work there. So if you guys do go online, anyone jump online to have a look at that, you'll be able to see all the people, all the companies that have been involved, and see the hard work that they've been doing. So yeah, thanks everyone who's been involved so far. Best of luck to everyone that's still working on the main challenge as well. And yeah, thanks again, Peter and Christie. Appreciate your time.
Yep. Thanks, Holly.
Thanks, Holly. Thanks, everyone.